أهلا بكم مرة تانية في كايرو دار. My dear student of the third secondary stages, welcome back again in a new revision of algebra. We have had finished together the last session the first part of the final revision of algebra, and we discussed it together and covered 9 problems, talked about the permutation and the combination, also binomial theorem and complex number. Now we are going to discuss the final 2 parts, which is talking about the omega, the cubic root of unity, and the other is talking about the determinant. Let's go first to discuss with the first problem today. Find the value of. Find the value of. This is a bracket, and k minus 1 over 1 plus omega plus k plus 1 omega square all power of 8, where k belongs to R and omega, as we know, is the cubic root of unity. This is our solution together now. Shall we start? First, we have to try to make a simplest form about this bracket. This is k minus 1 over, as we know, 1 plus omega equals negative omega square, plus k plus 1 omega square all to the power of 8. So we have negative times negative positive, then it will be k plus k minus 1, and this is negative omega square, negative by negative positive, and the omega square we can replace it by omega in the numerator, plus k plus 1 times omega square all power of 8. We have to remove brackets. We have k plus omega k minus omega plus omega square k plus omega square. So, as we know that k plus omega k plus omega square k equals 0, so which is left now? The left is omega square minus omega all power of 8. As we know, omega square minus omega equals positive or negative root 3 I all power of 8. So positive or negative and even power, it will be positive. Root 3 power of 8 equals 81. I power of 8 equals 1. Then the value is 81, and this is the answer of the question. Now we are going to move to solve example number 2. If omega is 1 of the cubic root roots of unity, prove that A plus B omega C negative 1 and omega determinant square plus omega B negative 1 A omega plus C power of 2 plus omega power 4 A negative 1 and C omega plus B power of 2. This expression equals 0. First, we have to expand each determinant by using the cross multiplication like that. So it will be A omega plus B omega square minus negative 1 times C means negative C, negative, negative, positive C, all power of 2 plus also omega times A omega, it will be A omega square plus C omega plus B all power of 2 plus the third omega power 4 means omega, it will be C omega square plus B omega plus A all to the power of 2. Now we are going to take omega as a common factor here. So we have A plus B omega. By the way, C means C times 1. 1 is omega power 3. We can write it like C omega 3. Then if we need to take omega from here, it will be C omega square, and this is bracket power of 2. Also, here we will take omega square common factor. It will be A plus, this is omega means omega power 4. Take omega square, it will be C omega square, and this is B omega all power of 2 plus third one, keep it as it is, A plus B omega plus C omega square all power of 2. Now this is omega square and the bracket A plus B omega plus C omega square power of 2 plus omega square power 2, it's omega power of 4, and the bracket again A plus C omega P omega plus C omega square power of 2, and then plus A plus B omega plus C omega square power of 2. Take the bracket as a common factor, A plus B omega plus C omega square power of 2 as a common factor, which is left omega square. Omega power 4 means omega, and if we take this as a common factor, left is 1. So omega square plus omega plus 1 is 0 times the bracket again. The final answer equals 0, and this is the requirement, or this is the proof. Now we are going to solve the next one of the most important problem. If 1 and omega square are the cubic roots of 1, prove that omega square plus 2 omega plus 3 over 2 omega square plus omega plus 3 plus omega square plus 2 omega plus 6 over 2 omega square plus 3 omega plus 4, all of this power 3 equals 27. How could we solve this problem? First, we have to simplify each of them. How could we do this? Like that. Omega square, 2 omega means omega plus omega, 3 equals 1 plus 2. Also, 2 omega square means omega square plus omega square plus omega plus 1 plus 2. Also, we will do the same to the next or to the second fraction. Omega square, 2 omega means omega plus omega plus 1 plus 5. Denominator, 2 omega squares mean omega square plus omega square plus omega plus 2 omega plus 1 plus 3, or we can say that we have omega square plus omega square, and this is 1, 4, we can make it 1 plus 3 or 2 plus 2, and then we can make this 2 omega square. By cancelling, omega plus omega square plus 1 equals 0, so which is left here? Omega plus 2. Omega square plus omega plus 1 equals 0. This is omega square plus 2 plus omega square plus omega plus 1. Then we have omega plus 5, and 2 omega square plus 2 omega plus 2 also equals 0. Then omega plus 2 left. By making common denominator, multiply the two denominators. Omega square plus 2 times omega plus 2, omega plus 2 times omega plus 2 times omega plus 2 plus omega square plus 2 times omega plus 5. By expanding the numerator, all power of 3, don't forget to write the bracket. So we have omega square plus 4 omega plus 4, and this is omega power 3 plus 5 omega power 2 plus 2 omega plus 10. Here we have omega square omega power 3 plus 2 omega square plus 2 omega plus 4 power of 3. Then omega power 2 plus 5 omega power 2, this is 6 omega power 2. 4 omega plus 2 omega equals 6 omega, and this is 4, and omega power 3 means 1. 5 plus 10 equals 15. Omega power 3 equals 1. 1 plus 4 equals 5. 2 omega square plus 2 omega, and we have 5. Take 2, 0, then we have the denominator equals 3 now. All power of 3. Okay, let's move to simplify again. 6 omega square plus 6 omega. We have 15. We can make it 6 plus 9. And this is 3. Don't forget that 6 omega power 3, omega power 2 plus 6 omega plus 6 equals 0. So we have 9 over 3 all to the power of 3 means 3 power of 3 equals 27, and this is the final answer, or the left hand side. Let's move to another important problem. If omega is 1 of cubic roots of unity, then form the quadratic equation whose roots the first root is a equals 2 plus omega over 1 minus omega. The second root is b 2 plus omega square over 1 minus omega square. When we are going to form the quadratic equation, as we know that the equation will be x square minus sum of two roots times x plus product of two roots. Then our steps depends now to get the sum of the two roots and the product of these two roots. First, a plus b, this is the sum. It will be 2 plus omega over 1 minus omega plus 2 plus omega square over 1 minus omega square. That's equals to 1 minus omega times 1 minus omega square 2 plus omega times 1 minus omega square plus 2 plus omega square 1 minus omega. By expanding, two times 1 is 2 minus 2 omega square plus omega minus omega power 3 minus 1 plus 2 minus 2 omega plus omega square minus 1 over 1 minus omega means 1 minus omega square minus omega plus 1. That's equal to 2 omega square minus 2 omega minus 2. This is 0. Keep these 2 and negative 2, negative 2 squared. It will be 2 minus omega square minus omega over 2 minus omega square plus omega. Take negative as a common factor. 2 minus omega square plus omega over 2 minus omega square plus omega. That means 1. And now 1 is the sum of the roots. Second, the product A times B. A times B means 2 plus omega over 1 minus omega times 2 plus omega square over 1 minus omega square. It will be 4 plus 1, 2 times omega square, 2 omega square plus 2 omega. Take 2 common factor, it will be omega square plus omega. Also in the denominator, as the previous, equals 3. So we have 4 plus 1, 5, minus 2 equals 3 over 3 equals 1. Then the equation will be x squared minus x plus 1 equals 0, and this is the final answer, or the quadratic equation. Let's move to discuss about a new part of the algebraic or the determinant. This is the Cramer rule. Use Cramer rule to find the solution set of the following equations. This is the equations. First, x plus y plus z equals 1. Second, 2x plus 3y plus 2z equals 0. Third, x minus y equals 3. First of all, we have to make the determinant delta of coefficient, and we have to simplify it together. First, it will be 1, 1, 1, 2, 3, 2, 1, negative 1, 0. Let's try to expand this determinant. We will do the first one and the other will be the same. We will take the first row 1 and the codeterminant, minus 1 and the other codeterminant, positive 1 and the third codeterminant. First 1, it will be 3, 2, negative 1, 0, 1, 2, 2, 1 and 0. First row, move row and column, it will be 2, 3, 1 and negative 1. by calculating 3 times 0 0 minus negative 1 times 2 minus negative 2, it will be 2, minus 0 minus 2, it will be 2, plus negative 2 minus 3, it will be negative 5. Again, we have 2, 3, 2, 1, negative 1, 0. So it will be 0 minus minus 2, it will be positive here. So the final answer will be negative 1. Now we have to make the determinant of delta x equals, by removing the first column and keep the others 1, 3, negative 1 and 1, 2, 0, and replace it by the numbers of the free parts, which is 1 and 0 and 3, and calculate the value of the determinant x. So we will get that delta x by using the same first row or first column. Delta x will be negative 1. By using delta y again, as we know, delta y, it will be 1, 2, 1, 1, 2, 0, and change the middle by 1, 0, 3. So delta y will be 2. Also, we have to calculate delta z equals 1, 2, 1, 1, 3, negative 1, and change the third one by 1, 0, 3. So the delta z, sorry, it will be negative 2. So as we know that x equals delta x over delta, that means x will be negative 1 over negative 1, it will be 1. Also y equals delta y over delta, that means 2 over negative 1 equals negative 2. And finally z equals delta z over delta, that means z equals negative 2 over negative 1 equals 2. Now the solution set equals 1, negative 2, and 2. By finishing this problem, then we have covered the second part of the final revision of the algebra. As we notice that there is something only something left, that which is talking about the properties of the determinant. We will discuss about it later inshallah, and we will go in the next time to start our final revision about the calculus. أترككم في رعاية الله، والسلام عليكم ورحمة الله وبركاته.